Hi, welcome to Invented Arizona. I'm Paul Tumarkin.
And I'm Taylor Hudson.
We are with Tech Launch Arizona, the office of the University of Arizona that commercializes inventions stemming from research. In this edition of our podcast, we're talking with Gayatri Vedantam. She's a professor in the School of Animal and Comparative Biomedical Sciences in the UA's College of Agriculture and Life Sciences.
She and her co-inventor Vish, Viswanathan, have developed a new technology for preventing and treating the Clostridium difficile, or C. diff, bacterial infection in the gut. So Gayatri, let's start with what the C. diff bacteria is for those who don't know.
So Clostridium difficile is an enteric pathogen. That means it's an organism that causes disease in the gastrointestinal tract. And it is a gram-positive bacterium and an organism that forms spores. And so when Clostridium difficile is exposed to any sort of harsh condition, it changes into this very hardy, inert structure that can survive for a very, very long time on surfaces. And it's a real problem because it's ubiquitously present everywhere in the environment, including in our hospitals and our communities.
All right, so it takes a certain kind of condition for someone to get an infection like this. What things do we do that create these kinds of conditions where the bacteria can grow?
Okay, that's a great question. So Clostridium difficile infection, or CDI, is caused when the normal microbiota, or the good bacteria, the good microflora in our intestinal tract, is depleted or suppressed. And most commonly, this happens upon antibiotic treatment. So many humans and animals will get antibiotics either prophylactically or preventively, or therapeutically, or for treatment. And one inadvertent byproduct of that antibiotic treatment is that all of our good flora are suppressed. And when good bacteria are suppressed in the GI tract, that means that niches become available for pathogens like Clostridium difficile to now enter and colonize. And like I said previously, this is a pathogen that's present ubiquitously in the environment. So contact with surfaces which contain the spores, or even any kind of object in the hospital or in the community that has those spores, result in Clostridium difficile entering the GI tract and essentially colonizing the vacant landscape that's now available because of antibiotic suppression. It affects about up to 1 million people in the United States. And if it's not diagnosed quickly enough and not treated properly enough, it is also associated with about 30,000 fatalities.
What type of symptoms will someone with a C. diff infection experience?
So once the organism gets into the intestine and establishes a foothold, it might produce up to 3 different toxins or molecules that cause diarrhea. And so the disease is actually a diarrheic disease. And it's very difficult to treat because the treatment is more antibiotics. And obviously, continued use of antibiotics further suppresses the microbiota. So it's an ironic offshoot of modern medicine.
Wait, so this sounds like kind of a vicious cycle. You're treating something that antibiotics caused with antibiotics. So for your technology, are we talking about a prevention or a treatment?
Well, we hope it'll do both. So the goal of the research in our laboratory is to try to ultimately look for interventions to prevent or treat C. difficile infection without the use of antibiotics. And this technology that we have right now is based on something that I said earlier, which is all this vacant landscape that opens up after antibiotic treatment. And our technology is based on the premise that if we can colonize that landscape with good bacteria that occupy the same niches that C. diff would occupy, we can prevent the establishment of any C. difficile spores that get into the GI tract and then settle in or find a home. So our technology actually uses genetic engineering to manipulate good and safe bacteria to express proteins that C. difficile would normally express on its surface and use to colonize the GI tract. So we are pre-colonizing the GI tract with our agent that essentially is designed to prevent further occupancy by Clostridium difficile. That would be a preventive. And the scientific basis of this project is that if we can prevent colonization of Clostridium difficile, then we don't have to worry about the downstream impacts of the disease. The organism is only going to produce toxin very late in its growth and cause all of the problems that it does if it's allowed to linger. And if we prevent the establishment in the first place, we won't have to worry about lingering organisms. The hope is that we can also use this technology to knock any existing C. difficile organisms off their perch, so to speak. That would be a therapeutic option, and we're developing that right now.
So we know there are different strains of C. difficile. Will your technology be applicable to variations in the bacteria?
So I'm really glad you're asking that question. That's actually an outstanding question. One of the big worries or the concerns in the C. difficile research area is that this organism exhibits incredible genetic diversity. So we use something called a molecular typing method to classify C. difficile into all the different flavors, of which strains are some of those flavors. And right now there's over 500 different ribotypes or molecular types of Clostridium difficile, many of which, if not all of which, are circulating in North America. And our surveillance in Tucson says we have many different flavors in our Tucson area hospitals. So our technology was specifically engineered to be widely applicable and prevent infection caused by multiple different C. difficile strains. So when we did our preliminary studies, we actually tested it on all the circulating strains of Clostridium difficile in the southern Arizona area, and those studies are obviously continuing. But you're right, our technology really is not going to be very useful if it doesn't prevent disease caused by all the different flavors of C. difficile. So it is engineered to do exactly that.
Once it's available to the public, how will we be able to take it?
The dosing of the technology is actually going to be based on safety. So right now, the way that we've designed it is that our technology will not actually stay in the GI tract very long and further disrupt any of the microbiota that are trying to come back. So we actually see this technology as a use it when you need it, or use it just before you need it type of technology. It will require once daily dosing at this point, but in our laboratory studies, as few as one single dose of the technology is enough to actually prevent the disease of the organism. But the recommendation is going to be that we take it once a day. It'll be less than half a teaspoonful of a yogurt-like formulation.
Well, that sounds easy enough. Thanks, Gayatri, so much for coming on the podcast and sharing your technology with us today.
I would like to say a huge, gigantic shout out to the people that work in our laboratory. None of this happens without the incredible effort that the whole team puts together, and I don't think we could ask for a better, more dedicated team. We also have veterans in our laboratory that for whom this disease is a huge problem, and so we have students that actually served in Iraq and Afghanistan, finished their tour of duty, and came back and are working in the laboratory to solve this problem that many of their members of their community are facing or have faced. And I think it's an incredible testimony to their hard work and effort that our technology is getting off the ground. So I would like to acknowledge them and all of our collaborators here at the U of A and at our hospitals in Tucson.
Wow, Taylor, that was a great conversation. Thanks for getting us some time to talk with Gayatri. And thanks to all of you for listening to Invented Arizona. For more information about this invention and all the other great inventors and inventions from the University of Arizona, visit TechLaunch Arizona on the web at techlaunch.arizona.edu.
We are at TechLaunchAZ on Twitter, and you can also find us on Facebook and LinkedIn.
And as always, please subscribe to our monthly newsletter for stories, updates, and events from around the University of Arizona ecosystem.
You can find that at bit.ly/TLA subscribe. Thanks for listening.